Okay, benzene mechanism stretch and challenge. I'm putting this question on because more and more in the past papers we've seen the benzene mechanism, but what they're doing in more recent papers is um, adding the difficulty on. So they're giving you something you haven't seen or isn't exactly on the specification and expecting you to apply your knowledge to that new situation. So this question here, the actual alkylation of benzene is not on our specification, but this question uses all the principles that we have looked at, so we can tackle it. So the question runs like this. Ethyl benzene is manufactured using a reaction between ethene, benzene, in the presence of HCl and aluminium chloride, now both as catalysts. The electrophile in this case is CH3, CH2+, which is our standard positive electrophile for a benzene mechanism. So we've got to explain how the electrophile is formed first of all, and then we've got to give the mechanism. The tricky part of this question is the first part, explaining how ethene, HCl and aluminium chloride will react together to produce our electrophile CH2CH3. So we'll look at this first. So focusing on this particular part of the question, what we've got to think about is exactly how we're going to form CH3CH2+. We've got HCl and AlCl3 to help us. Just think about that for a moment. Electrophilic addition. Does the intermediate, the carbocation, in electrophilic addition look similar to this? Pause. Then go on to think, can you begin an electrophilic addition mechanism with what we've got in this question? So with ethene, HCl, and chloride. Have a go at starting that mechanism and see if you can get an intermediate carbocation. Okay, what you should see that we get our ethene molecule and we get our HCl. We'll bring them together. We know that on the HCl we're going to have dipoles. Chlorine is more electronegative, so the hydrogen will have a delta H plus, chlorine a delta H minus. So for electrophilic addition, my curly arrow comes from double bond to delta H plus. Then at the same time I have to break my HCl bond now. Once I've done that, I am left with my carbon cation. So I get my intermediate carbon cation being formed. That is what we want. So we've taken, in this question we weren't quite sure about it, we've taken electrophilic addition back from AS, we've done that, and we've got our electrophile that we need. The key question is, of course, we also get this chloride ion, which normally would form a bond to make chloroethane. But what we've got here, key thing, aluminium chloride. What's going to happen is, since this is in the presence of aluminium chloride, rather than the chloride ion forming a bond with our carbon cation, it's going to go across and form a bond with our aluminium. So we get our normal AlCl3 4 minus. That frees up our carbocation here to go on to react with benzene in an electrophilic substitution reaction. So that's the first part of the question. We've used electrophilic addition to produce our electrophile. It's not a mechanism we've looked at, it's not a mechanism on our specification, but you have the ability to produce that carbocation. Now let's look at the second part of the question. Here we've just got to give the rest of the mechanism. So we've got our electrophile. We've showed how that's been formed. So we're just going to take our benzene as before. Our curly arrow to the electrophile. So this mechanism is now exactly the same as we've done before. We go and we form our intermediate.